Dear students, in this lecture I should discuss some problems on analytic functions to verify the Cauchy-Riemann equations in Cartesian and polar forms, and also by taking some problems to find the derivative of an analytic function. So in which what are the learning objective of this lecture? In this lecture, the objective is to understand the verify the Cauchy-Riemann equations for given problems, and also to the procedure to find the derivative of an analytic function. So it means whatever the given function, you can verify that CR equations in which also to find the derivative of that given function. And what is the procedure to find the derivative of an analytic function? In first step, what you do that you take the given problem, and in which the given problem is function is Cartesian function, or else it is a given function is polar function. That depends on the function. You should take either polar or Cartesian form. So then you find here u and v that, and then you verify the CR equations for u and v. That CR equations is ux equal to vy and uy equal to minus vx. Or if it is the given function is in polar form, that u and v are in polar form, so that you can verify these CR equations. U are equal to 1 over r v theta and u theta equal to minus r into vr. Ur is nothing but dou u by dou r, and v theta is nothing but dou v by dou theta, and u theta is dou u by dou theta, vr is dou v by dou r, and here also ux is dou u by dou x and vy is dou u by dou y, and ui is nothing but dou u by dou y, and that equal to minus dou v by dou x. You can verify these CR equations, and then you can find using the derivative results. Derivative f dash of z equal to ux plus I vx means dou u by dou x plus I into dou v by dou y. Or if it is in the polar form, that is f dash of z equal to e power minus I theta into ur plus I vr. That is dou u by dou r plus I dou v by dou r. Then we get a f dash of z, means a derivative of that given function. So to convert the derivative of that function in terms of z, you can use the Milne-Thomson method. That in which it states that you can change only that final whatever the f dash z, it should be in terms of z, so that you can change, that is the x, you can convert it only, that is x replaced by z and y replaced by 0 if it is in the Cartesian. If it is in the polar, so that just you can replace here r replaced by z and theta replaced by 0. Then we get a f dash of z. Now I shall take some problems to verify the analytic functions and also to find the derivative of that given function. So show that the following functions are analytic, and hence also find the derivative of that. So you take one function here f of z, and that z equal to z plus e power z. Actually, what is the usually derivative of this function f dash of z is nothing but 1 plus e power z itself. So that we can find that same answer by making use of this complex analysis concept. So that we know that you can replace here z replaced by complex variable x plus iy and w replaced by u plus iv, that and w equal to f of z. So that totally this function can be taken in this way, w equal to z plus e power z. Then this w replaced by u plus iv, because it is a complex function of complex variable, and it is a function of complex variable, and z replaced by x plus iy. E power z is nothing but e power x plus iy. Just you can simplify this here. This e power iy can be taken in the form of cos, trigonometry form, cos y plus I sin y, and then you can separate the real and imaginary terms. So those which respectively, that is u and v here, u plus iv. So that you take, that is u is this and v is y plus e power x sin y. And just you can differentiate with respect to x and y here. We got it, this one. And you can differentiate again with respect to x and y in v. We got it, these relations. So then now to verify that CR equations, ux equal to vy. Just you can see that ux equal to vy, that is, and also uy equal to minus vx. So that these CR equations are satisfied. Thus this given function is an analytic function. And also find that is the and that is you can find also that is the derivative of this function. Just you can take a derivative this here in which given function is nothing but what f dash of z equal to ux plus ivx, and then you can ux is as you have got it, replace it here, and vx is also you can replace that. Just you can substitute those ux and vx, and finally we got it this relations, that is nothing but cos y plus I sin y is nothing but e power iy, and this is nothing but e power x plus iy. E power x plus iy, that is, since x plus iy is z, so that it has to be, this is e power z, and then it is the derivative of 1 plus f dash of z. So that is a given function z plus e power z. As I told you, that is the usual derivative of function. It is z plus e power z is 1 plus e power z. We have got it by this CR equations as well as this complex concept. We have got the same answer. And then second problem, function is given is logarithmic function. Usually we used to convenient by taking the polar form, so that that's why we can take it, replace it here, z equal to re to the power of I theta, and w replaced by u plus iv, and that log z is log re to the power of I theta, and just we can take the logarithmic properties, so that log r plus log e to the power of I theta is nothing but I theta. Just we comparing real and imaginary terms respectively, that is u is log r and v is theta itself, and just you can differentiate r and theta in u, and here also differentiating theta and r in v also partially. So then you can see the CR equations, u r equal to 1 by r v theta, and vr equal to minus 1 by r u theta, or u theta equal to minus r into vr. So that CR equations are satisfied. So then we have that by taking another results, we have got it here by taking another results, that derivative results, function f dash of z equal to e power I theta into ur plus ivr. If this is derivative, we know that in the polar form derivative. Just you can replace that results of ur and vr, that is dou u by dou r plus dou v by dou r, dou v by dou r. Just you can replace those results. It has to be, turns out to be 1 over r into e power I theta. R into e, since z is r e to the power of I theta, that you can replace it 1 by z. As we know that the derivative of log z is 1 by z, so that we have got the same results by this concept. And third problem, as we have, that is here, so that function f of z equal to z3, that z cube, so that it is also analytic, and also find the derivative of this. And just you can take it again here as well, that by taking the z equal to x plus iy and w equal to f of z equal to w, that. And same thing we can have, that is the results we have arrived at, you can expand that x plus iy whole cube, expansions of this cubic terms, so that we have got it, that is u plus iv, that where u is x cube and minus 3xy square and v is 3x square y minus y cube. Just you can differentiate ux and y in u partially, and similarly x and y partially in v that. And just you can verify this here, just you observe the CR equations, this function is also verify the CR equations. So that's why this function is an analytic function. Now you can find that is the derivative of that given function, that is ux plus ivx. Just you can replace that results of ux and vx, then make use of Milne-Thomson method, x replaced by z and y replaced by 0. Finally, we arrive at the form, so that f dash of z equal to 3z square. As we know that f of z is z cube, derivative of that is 3z square. Same results as we have got by this this concepts. One important note, if it is in the function is given function in the trigonometric form, so that before understanding that, finding those analytic function as well as derivative, so that we can have that is the sine of ix equal to I into sine hyperbolic x, and cos of ix is always cos hyperbolic x. So now I should take problems based on this trigonometric function as well as hyperbolic functions. Show that function is sine z, it is analytic, and hence find derivative of z. So that the given function is sine z, just replace z replaced by x plus iy, and you make use of the sine of a plus b formula, that is sine of a plus b sine a cos b plus cos a sine b. Just you can take it sine x here, sine cos iy plus cos x into sine iy. As we know that results of this here, just replace cos iy is cos hyperbolic y, and replace sine iy is I into sine hyperbolic y. That is, you can already, it is separated real and imaginary parts, where u and v are here, it is sine x cos hyperbolic y and v is cos x sine hyperbolic y. Just differentiate with respect to x and y partially in u and v, and compare, that is the ux equal to vy and uy equal to minus vx. This implies that u and v satisfy the CR equations. Hence, this given function is analytic function. That given function is sine z. That sine z is also analytic function. Now we can find that is the derivative of that given function, that sine z. Just you can take it a derivative. That derivative results ux plus ivx. Just replace that ux and vx in here, and make use of that Milne-Thomson method by replacing x replaced by z and y replaced by 0. And finally we got, that is the derivative of sine z is cos z. And now similarly you can take the hyperbolic function, so that it is also, that is sine hyperbolic cos hyperbolic function, its derivative is sine hyperbolic z. So that just consider those and replace, that is z equal to x plus iy. As we know that cos hyperbolic z is z cos of x plus iy, that you can have, that is cos hyperbolic x is always e power x plus e power minus x by 2. That results you can use it here, or else it is formula you can use it here, and then you can have a result should be in this form. That it is here also, that is what we have, that is, so that we have this here. Just you can have, that is the, it is again nothing but e power x plus e power minus x by 2 is cos hyperbolic x, and e power x minus e power minus x is nothing but sine hyperbolic x. So that you can take it u and v, those two, and differentiate u and v in x and y respectively, and compare, that is the ux equal to vy and vy equal to minus uy equal to minus vx. So then this given function is analytic. So now we should find out, that is the derivative of that ux plus iv. Just you replace, that is ux and vx in that derivative, and replacing and